Good morning, guys.
Morning, sir.
Morning. Thank you, Nina. I say thank you, Nina.
For what, sir?
For let everyone know this thing.
Oh, no problem.
Okay, so let me do this thing. First of all, Solomon Harris is here, one, then Rodriguez is here, then Nathan Light is here, then Campbell is here, then Alex is here, and then Nick is here, then Paul Mustaine is here, then Ismail Taylor is here. What's wrong with Hart? Margie? Hart and Margie.
I know Quinn had texted me and told me he was having a little bit of issues, but he should be
he's
getting
here. He's here. Yeah,
Okay.
Quinn is here. Quinn is here. Margie is not here. And Jane Levin. So I think everyone is here, right? What's about William? William is not here. William.
I'm right here.
Oh, William is here. William, we are waiting for you.
Yep. Yeah.
Sorry, we're waiting for you, William. Ismail is here. Okay, everyone is here except Margie. William is, where is William? I lost him.
Hello.
He's here. William is here. Okay. My first question, how many of you went over the class work, whatever we did yesterday? Please be honest to yourself. One. Then, Alex, why not? Nathan Light, why not? I can see your face. See?
I was tired yesterday, sir. I plan on doing it today.
Nathan, please. Everyone is tired. You know what? You won't believe how many hours I'm working nowadays. You can't believe. Yeah. Yesterday, my calculus students, they had some problems, and I was working with them till 10:45 p.m. Yeah, and early morning, I just got up. I got up early in the morning too. So I'm so tired. Right?
Sir, I actually had a question about what we did yesterday.
Wait, Nina, wait. Do you remember yesterday we decided that I to spare 15 minutes with you guys for your questions for daily class notes? Do you remember this thing, Nina?
Yes, sir.
Okay, so I will give you that time. In that time, you can ask me the questions, okay?
Okay, thank you.
Everyone, please. And that's the reason I told you to go through the classwork so that you will have some questions and I can answer your questions, and that will start preparing yourself for the next stage. But if you don't work, no way, guys, no way. Will, what's the problem?
That's why I was late coming in, is because I'm finishing up because I'm taking 3 classes. Like I'm taking another one through.
Will, I'm sorry, but that is not my lookout.
I know. I was just finishing up while I was waiting, so I'm literally done now.
No, I'm not talking about this one. I'm just talking about our homework, our classwork, whatever we went for.
Yeah, that, since I still need to finish packing for my move, what I did was I'm trying to do all my work at the beginning of the week, which I went through and did my. What?
Please.
Hear me out. So I did my entirety of my Virginia Tech class work for the week yesterday. And then today I'm going through and finishing the work for my other class. And then tomorrow I'm doing all the work for this class. That way it's fresh in my head for the exam on Friday.
Again, let me remind you, last time I told you yesterday, every day you have to spend some time. So if you say that, as you said, that you're going to spend time tomorrow, that means you are not going to learn the things which I'm going to do today.
Well,
That's not allowed.
I'm going along with those as we do it.
No, so. I don't say that you are not a hard worker. I don't have any kind of problem. I mean to say, I don't argue. But main thing is you are giving weightage to other subjects, not this one. So that's what I don't want. I just want you to spend at least an hour on like this, right? I don't want you to just pay. I don't say that don't pay attention on the other subjects. No, you have to, but not the cost of my subject. Make sense?
Yeah, I still spend the most time in this class. If that makes you
Yeah,
feel better.
you have to manage your time, guys. You have to manage your times. These all are the excuses. Sorry, Will, but please cooperate me. If I will be upset, you won't like it. All you guys will not like it. So please keep our environment very healthy. Please keep our atmosphere healthy, and that way you can also learn some good things. I will also be happy with you guys. So please, I don't want to repeat all these things daily, please. So please take care. Gage Levine.
Yes, sir.
Gage Levine. Yes. Did you go over the stuffs yesterday?
Just a little bit, sir.
Little bit.
Like 20 or so minutes.
Don't do this thing, please. Please go through everything, please. Alex, this is last time, okay? I don't want to hear any kind of things, any excuses from anybody. Next time, please. And Ismail, it looks you didn't do anything.
No, I did. I reviewed for like an hour.
Okay. Solomon Harris.
Yes, I went through 4.1 and 4.2.
I can't hear you. I can't hear you. Speak loudly.
Can you hear me now?
Yes.
Yeah, I said I went through 4.1 and 4.2 and looked over the practice test problems.
Sounds good. Nathan Light. You already talked, right?
Yeah.
Yeah. Please be careful, okay? I don't want you to repeat the same thing tomorrow. Paul Mustaine.
Spent about 2 hours, I would say, and then did all the practice problems that's up to.
So nice. So nice. Ilyas.
I spent 9 hours on the road yesterday.
Say again?
I spent 9 hours on the road, sir, driving, going back and forth to Lexington and picking up my stuff. So pretty much from the time I got off of the class
If
until,
you are going to spend 9 hours for some other work today, listen that thing. I just want you to spend a couple hours for this one, okay?
yes, sir. That's
Please be careful.
the plan. That's the plan.
Okay. And who is left out? Nick Campbell. You're good.
I wasn't in the class yesterday, sir. I haven't had a chance to watch the YouTube video yet.
Why not? Immediately I posted the videos yesterday, immediately after the class.
I'm going to watch it as soon as we're
Then
finished.
you were not there, and I know you are a sincere guy. So only because of you, I posted the videos very immediately, just within 20 minutes after the class.
I'm going to watch it as soon as we're done here today, sir.
Yeah, without fail, please.
Yes, sir.
And who is left out? Marg is still not here. Queen Hart.
Yes, sir. I covered 4.1 yesterday as soon as I got home from all the appointments and stuff. And I'm covering 4.2 this afternoon.
Okay, but now tomorrow onwards or today onwards, try to cover everything, okay? Please.
Yes, sir.
Okay, guys, any question? Nina, go ahead.
Yes, sir. So I was looking at 4.1, and I understand how we check for the linearity, like if it's dependent or independent. And I understand how we get the C values for 1 because we can set sine and cosine equal to like tangent, and then that equals 1. I get that part, but I don't get how to find C1, C2, and C3 for like question B and question C, even though I know how to check for the
Ilyas, please pay attention here.
dependency. I get that part. I just don't know how to solve for the constants.
That is what question number, which one? Which question?
Question number 1, question number 1, B and C.
Question 1, B and C, are you sure?
Yes, sir.
Are you sure, Nina? Look at here. We went over question C yesterday. Do you remember this thing? We went over 1A and C. One day I give you B in homework.
Yes, I understand. I understand how to. I'm just not sure how to check for how to get the constants. I don't get it.
Okay, let me show you. Let me show it to you again.
I did how to do A, just not B and C. I don't know how to do this.
And that's what I'm telling you. I'm not taking A right now. I'm just taking C. Okay.
That's fine.
See, this was question number 1A, right? This is question 1A. Yes. 2A, right? This one is 2A. Anyway.
Yeah, that's 2A.
Yeah, yesterday. That's fine. Let me skip this one. No, not this one. I think something is different. No. Oops. Can you see here, Nina?
Yes, sir. Yeah, I get this.
Number 1, 3. Say again. This is number 1A or C?
That's A.
A. Okay, and you went through this one. Okay, and I saw that you can see the same thing. You can solve the same thing using Vronsky too. That's what we did. Okay, and let me go through that question. Okay, I can't find anything here. That sounds good. No problem. Let me do like this. Question number 1. Which one?
1B or C?
It's only one.
Either one. B or C, just the constant part. I understand.
Yeah, so I can solve only one. I am not going to solve both. So which one?
B is fine.
B is fine. Okay. Let me share my screen with you. And let me first stop this sharing and let me share my whiteboard so that now drawing and this one, okay, and this one. Will you please repeat the question for me? What is your F1x?
F of 1 equals X.
F1 equal to X, then F2 is?
X squared.
X squared, then F3 is?
4X minus 3X squared.
Okay, got it. And F4X is?
There is no F4.
There is no F4, just F1, F2, F3, F1, F2, F3, right?
Yeah, from negative infinity to infinity.
That sounds good. Because polynomial, so it is defined negative infinity to infinity, and there is no denominators. Of course, whole real line is the domain. Okay, now C1 F1x plus C2 F2x plus C3 F3x equal to 0. Nina, thank you so much. I like this thing, and I'm pretty sure that no one of you would be able to solve this one. Thanks for asking. That's the reason. That's what I appreciate. It clearly looks that you went through the assignments. That's good. Or whatever we covered yesterday in the class. This implies that C1 x plus C2 x squared plus C3 4x minus 3x squared equal to 0. Agree? Now, if I take suppose C1 equal to C2 equal to 1, suppose, because look at over here, here I have x, here I have x to the power 1. Always try to think like this. Here I have x squared, here I have x to the power x squared. So some kind of connection is there between this first term, second term, and this third term. Are you getting me? So think like this. Here I want 4x, but I have just x over here. I want 4x over here, 4x. So what I would say that I don't, okay, let me do like this. You can do this. Plenty of ways to solve the same example. First way is, let me first, excuse me. Let me do this thing and let me erase this part. Oops. So instead of taking C1 and C2, I would like to start this example from here. So let me start like this. Suppose I take, oops, sorry. Suppose I take, so if C3 equal to, suppose C3 equal to 1, means what the function I'm going to get? Here I'm going to get simply 4x minus 3x squared. Agree? And outside I have a plus sign. Am I right? Because C3 is simply 1. So if C3 equal to 1. Nathan Light, are you okay?
Yes, I'm okay.
Okay. Now I want 4x. Right hand side equal to 0. That means I have to cancel Nina here. I have to cancel everything. Here right hand side equal to, look at my cursor, right hand side equal to 0. I have 4x over here. I have simply x over here. So what I'm going to do, I'm going to choose my C1 equal to -4. So that I will be having -4x as my first term. Agree? Then after I require negative of 3x square. If I want to cancel this -3x square, I have to have my C2 equal to, suppose 3. C2 equal to 3. That means I will be having plus 3x square. And now you can see over here, this 4x square and plus and minus will get cancelled out. This plus and minus will get cancelled out and I'm getting 0. So my left side is equal to right side. That means equation is satisfied. This equation is satisfied only for your C1 equal to -4, C2 equal to 3, and C3 equal to 1. And you can see all my constants, C1, C2, and C3, all these constants, they are not 0. Agree? And because they are not 0, they are linearly dependent. Agree? Yes or no? Excuse me, guys.
Are we just assigning values to the constants so that everything cancels out and the equation equals 0?
That's
Yeah.
what I'm getting from this.
Okay, that makes sense. Thanks.
Sorry. So because my C1, C2, and C3, they are not 0, that means it is linearly dependent. Does it make sense?
Yeah, that makes more sense.
Yes, sir.
Okay. And I think C3 is not that difficult. It is. I mean, the third one is not that difficult. That third one is just similar to your first one. Sounds good.
That's a lot better. Thank you, sir.
No problem. So please try question number 1C. If you're not getting, let me know tomorrow. Okay, Nina?
Yes, sir.
Okay. Any other question?
Sir, I have a question.
Yes.
I have a question about 2B.
2B. What is 2B? First, let me erase this one. I need some space. So can I erase this part, guys? Nina?
Yes, sir. Yep.
Yes, sir.
All of you, can I erase this one?
Sure.
Yes.
Okay, so clear
sir.
all drawings. So let me erase this one. Okay, now go ahead, Paul.
Well, X, Y double prime plus Y prime equals 0.
X, Y, double, my bad. I'm sorry.
That's plus Y
Wait,
prime.
wait. Yes, X, Y double prime, then go ahead.
Plus Y prime
Plus Y prime, then
equals 0.
equal to 0, okay?
And Y1 equals natural log of X.
Oh, got it. Natural log of X, then
That's it.
you are looking for Y2, agree?
Yes. Oh, yes.
Okay, and that's the question, right?
Yes.
Yes. What is the formula? Give me the formula.
Well, I know you have to move the X over. So you get Y double prime.
I'm sorry. Wait. Okay, go ahead. What is the formula?
For the whole entire, for the thing? for y2 equals
Yes, y2 equal to.
y1 of x times the
What's going
integral.
on? Wait, something. Oh, I don't like this one. Yes, the formula is
y2 equals y1 of x
just y2 of x equal to y1 of x, then
times the integration
integration
of e to the power
e to the power
of negative, p of x.
negative p of x dx, right?
Yes.
This is the formula. Now, if you look at over here, my equation that is given like this, xy double dash plus y dash equal to 0. That means it is not in the standard form. My standard form is a y double dash plus by plus c equal to 0, where my coefficient of a must be equal to 1. That means I can write this equation in the form of, I can write this, what is going on? So I can write, just ignore this part, I can write y double dash plus, or let me write xy double dash plus 0y dash, no, it is not 0, it is 1y dash plus 0 times y equal to 0. Plus 0 times y equal to 0. If you divide by x, you are going to get y double dash plus 1 over x times y dash plus 0 times y equal to 0. Agree?
Yes, sir.
So now this one is in the standard form. This one is in the standard form. Y double dash plus 1 over x y dash plus 0 times y equal to 0. You can see over here my p, this is my p. This one is my p and this is my q. We don't want q. So I'm going to write y2 of x that is equal to y1. Y1 is the first solution you are going to get, you are given ln of x. And integration e to the power negative of 1 over x and dx and divided by x and square and dx. Am I right? That means I need to write like this, that this ln of x, I would say more precisely ln of x and square. So if numerator is easy, that is equal to ln of x, and then after I can write integration e to the power negative of ln of x and divided by, here it is ln of x and whole part square and dx. And this negative I would like to take it over here. So I can say, I can get something like this. Exponential and logarithmic function will get cancelled out, and I'm going to get that is equal to ln of x and integration 1 over x divided by ln of x and whole square and dx. Now if you would suppose ln of x equal to u, that means you're going to get 1 over x dx equal to du. 1 over x dx equal to du. If you plug the values over here, you're going to get that is equal to ln of x and integration 1 over x dx, that is equal to du. So it is 1 over u square and du. And that is equal to ln of x, 1 over u square is u to the power negative 2. Integration is u to the power negative 1 divided by negative 1. And plus c, we don't write c over here, right? So that is equal to negative of ln x and u inverse. U inverse is nothing but 1 over u. So 1 over u is 1 over ln x. This ln x and ln x will get cancelled out, and your answer is negative 1. What is the answer I gave it to you?
It's negative 1.
Okay, so you got it, right?
Yes, sir.
Guys, don't do like this. See, I saw number A and C yesterday for question 1, and Nina asked me B. So all 100% is solved now. Question B, I solved one or two examples. He asked me this one. That's fine, no problem. So I think almost 100% is solved for question B2. And now we are going to start. May I erase this part? Now I'm going to start our
Wait, not yet.
article 4.3. Article 4.3. Okay, I give you 1 minute, try to finish this one. Done? Hurry up, guys. This is not fair. I can't give you more than 2 minutes, please. Is it okay?
Sir, I'm good for you to remove.
Okay. So now let's start with this one. Article 4.3. Is everyone here?
Yes, sir.
Homogeneous linear differential equation with constant coefficient. Now we are going to solve actually the differential equations. But homogeneous means right hand side is equal to 0. So please make sure this thing. Homogeneous linear differential equation with constant coefficient. Second order differential equation. Which type of solutions we are going to get? First of all, please pay attention over here. AY double dash plus BY dash plus CY equal to 0 because right hand side equal to 0. That is why it is called the homogeneous equation. We don't know the solution, but suppose I say that y equal to e to the power mx is one of the solutions for this differential equation. Suppose I have second derivative over here, the highest derivative. So let me go through the first and second derivative. So I'm getting m e to the power mx and m square e to the power mx, m being constant. If you plug it back over here in the equation and e to the power mx is constant, just pull it out. Inside the bracket, you are going to get am square plus bm plus c equal to 0. If you use zero product rule, you are getting e to the power mx equal to 0, but exponential function never be 0. Look at over here, it's always increasing function. That means other choice is your quadratic equation is equal to 0. Your quadratic equation equal to 0. But if you compare this quadratic equation with this given equation, what I'm doing over here, what is the difference? Difference is your derivative or variable, dependent variable y is simply converted in terms of some constant m, am square plus bm plus c. That means actually we are converting our differential equation in terms of some algebraic equation. And this algebraic equation itself is known as the auxiliary equation. Once you have the auxiliary equation, quadratic function is there. What are the roots of this auxiliary equation? Roots of this auxiliary equation, second order means you have to have two roots. So m equal to negative b plus or minus square root of b square minus 4ac divided by 2a. If you want to write these two roots separately, that means you can write m1 equal to negative b plus square root of b square minus 4ac by 2a, and m2 equal to negative b minus square root of b square minus 4ac by 2a. So one is plus, one is minus. Two roots are there. But you don't know. This is just general. This is just the general solution. You don't know which type of solutions, which type of nature of this a, b, m, a, b, c will be there. That means which type of nature will be there for m1 and m2. It may possible that both of these roots are real numbers, but distinct. It may possible that both of these roots are real, but the same, 2 and 2. As for example, suppose m minus 4 whole square, right? So m equal to 4 and 4, like this. So first case is roots are real and distinct. Second case is roots are real and same, or you can say repeated. Third case is roots are complex conjugate of each other. Suppose one of the roots is m equal to a plus ib or 2 plus 3i. Second root is 2 minus 3i. So that is called complex conjugate of each other. Fourth root is suppose repeated complex conjugate of each other. Right? Roots are repeated complex conjugate. That means 2 plus or minus 3i and again 2 plus minus of 3i. This type of roots you are going to get when you solve this algebraic equation and this type of algebraic equations. Okay, guys. So what will happen if for all these 4 different cases, if my roots are real and distinct in that case, again, there is a big theory. If somebody is interested, I can send the theoretical portion to you too. But I just would like to skip that part over here. And I just want you to keep in mind this thing that whenever roots are real and distinct, because I have taken my solution in terms of the exponential function e to the power mx. So my m1 is e to the power mx. M1 is this one, m2 is this one. So whenever these two roots are real, real numbers and they are different. In that case, y equal to c1 e to the power m1 plus c2 e to the power m2x. c1 e to the power m1x, c2 e to the power m2x, like this. Suppose your roots are real and repeated means same root. In that case, c1 e to the power m1x and c2x, you have to multiply by 1x over here because your c1 e to the power mx and c2 e to the power mx are same. Look at here, because your m1 and m2 are same. Suppose you don't write m here, x here. What will happen? Taylor. Suppose you don't write x here. c1 e to the power mx and c2 e to the power mx. That means you can take e to the power mx common and you are going to get c1 plus c2. c1 plus c2 is just one constant. I can write capital C e to the power mx. See, I have second order differential equation. I'm getting just one root. And that is not allowed. That is not, that means that violates the rule. And that's why we are multiplying our second root or first root, whatever you want, just by 1x. So that we will be having two constants. Otherwise, we were getting just one constant, right? Again, order of the differential equation must be equal to number of arbitrary constants. So here I have two arbitrary constants for second order. Here I have now two arbitrary constants because I multiply by x. So I cannot take this e to the power mx out because again, we are getting c1 and c2 separately. Third case. Suppose roots are complex conjugate of each other. Suppose roots are complex conjugate of each other. What will happen? If roots are complex conjugate of each other, suppose first root is alpha plus or minus I beta, second one is alpha m2 alpha minus I beta, alpha plus I beta, alpha minus I beta. Just like this one, suppose this alpha plus I beta, alpha minus I beta, we don't know. So let me write it down in terms of m1 and m2. So c1 e to the power m1x plus c2 e to the power m2x. I can separate it out, e to the power alpha x common and e to the power, I mean to say, e to the power alpha x times e to the power I times beta x. Here you also e to the power alpha x and e to the power negative I times beta x. E to the power I times beta x and negative plus and minus, they are separated by plus and minus. But e to the power alpha x is common, so let me pull it out. Inside the bracket, c1 is there, e to the power I beta x is there, c2 is there, e to the power negative I beta x is there. But e to the power I theta, your second page formula sheet below unit circle. Euler's or Euler's identity, e to the power I theta can always be written as cosine theta plus I times sine theta. So here I can write cosine theta, cosine bx plus I times sine bx, and cosine bx, because cosine is an even function, minus I times sine bx as sine is an odd function. Cosine of negative of beta x can be written as cosine of beta x because cosine is an even function. And cosine of negative of beta x can be written as negative of sine of beta x as sine is an odd function. Look at here. So I just took this e to the power alpha x out, and then after I collected the terms cosine beta x and I times I sine beta x, I mean I just used the Euler's identity over here and here, even and odd function. Then after I collected all my cosine terms, look at over here. So e to the power alpha x, this one as it is, e to the power alpha x, this one is c2, even functions of cosine beta x, odd functions of negative sine beta x. I have cosine beta x over here. I have cosine beta x over here. Let me collect this cosine beta x. So I'm getting c1 from here and c2 from here, e to the power alpha x common and cosine beta x common. Same way, I am having I times c1. Look at here, I times c1 and negative of I times c2 and sine beta x. But this one is constant. This one is constant. So let me take this one as c1 cosine beta x and c2 cosine beta x. That means whenever roots are complex conjugate of each other, in that case, we are going to write the solution in the form of y equal to complex conjugate means alpha plus or minus I times beta. So e to the power alpha x, real number, cosine c1 cosine beta x plus c2 sine beta x, right? Alpha plus or minus I beta, alpha I'm going to use over here and beta will be used over here and here. Are you getting me, guys? Are you getting me? You have to memorize these 4 rules. There is no option, please, guys. You have to memorize these 4 rules that when roots are M1 and M2 are two roots and roots are real and distinct, solution is y equal to C1 e to the power M1x plus C2 e to the power M2x. Suppose roots are real and same, means M1 equal to M2 equal to some M. Solution is y equal to C1 e to the power mx plus x times C2 e to the power mx. Suppose you have three different roots. We are working with cubic equation. Suppose M1 equal to M2 equal to M3 equal to M. In that case, this repeated roots solution will be written as y equal to C1 e to the power mx plus C2 times x e to the power mx plus C3 times x square. You are increasing the polynomial x, x square, x cube, and so on, depending on the nature of the equation. Biquadratic roots and all four roots are real and same. Four roots, so C1 plus C2x plus C3x square plus C4x to the power 4. Sorry, C3x square and C4x to the power cube e to the power mx. That will be the solution. That will be the solution. Okay, and the last part is case 4. Suppose your two complex roots, alpha plus or minus I beta, two complex conjugate roots are repeated. Roots are repeated for complex conjugate. Again, C1, instead of writing C1, you can write C1 plus C2x cosine beta x and C3 plus C4x sine beta x. C3 plus C4x sine beta x. Whatever the rectangles block I put over here, I put it over here, you need to memorize all these forms. Again, I repeat, if roots are real and distinct, solution is y equal to e to the power C1 e to the power M1x plus C2 e to the power M2x. If roots are real and same, solution is y equal to C1 e to the power mx plus C2 times x times e to the power mx. If it is cubic equation, C2 times x square times C3 times x square times e to the power mx. If it is biquadratic equation, add one more term, C3 times C1, C2, C3, C4 times x cube e to the power mx, like this. If roots are complex conjugate of each other, in that case, your solution is y equal to e to the power alpha x, C1 cosine beta x plus C2 sine beta x. And if roots are repeated complex conjugate, Nina, here please. Repeated complex conjugate, then e to the power alpha x, C1 plus C2x cosine beta x, C3 plus C4x sine beta x. So you need to memorize all these four forms, please. First example. It's a biquadratic equation. D to the power 4y dx to the power 4 plus 13 d square y over dx square plus 13y equal to 0. 13y equal to 0. I think this is just the first example. So let me do let me do one thing. Let me explain to you. Ilyas, please open your practice test and please give me this first line. This line. Ilyas.
Yes, sir. I have the practice test open. Which question are you looking for?
Question number 3B.
3B. Okay.
Yeah, I just want you to repeat this question so that I can explain to you, because I'm going to start now. Just give me a minute, please.
Yes, sir.
Okay, so let me stop sharing this one and let me start with the whiteboard. Help me.
Okay, so it starts out as d to the 4y over dx4.
Then
plus 13 d to the 2y over dx squared.
Then
plus 36y.
Okay.
Equals 0.
Okay, guys. So first of all, you know this thing that d by dx, that is nothing but my operator d, right? That means I can write this one in the operator form, d to the power 4 plus 13d square plus 36, and my y is out, and that is equal to 0. My y is out, and that is equal to 0. If I want to write the auxiliary equation, a dot e dot, that means I'm converting my operator in the form of the algebraic number. Constant m square plus, sorry, not m square, it is m to the power 4 plus 3m square plus 36, and that is equal to 0. Plus 36 equal to 0. Now, you don't know how to solve this m biquadratic equation. This is, of course, the easiest one, but suppose you are given some biquadratic equation or cubic equation, maybe you will get stuck. So let me do one thing. Let me put one symbol over here. Suppose my m square equal to p. If I use m square equal to p, I'm going to get, here it is p square plus 13p plus 36, and that is equal to 0. If you solve this one, this implies that p plus, sorry, what are the factors? P plus 9 and p plus 4. Agree? P plus 4 equal to 0, because p square plus 9, 4 and 4p, 9p and 4p equal to 13p, and 9 4s are 36. That means I'm going to get, now let me plug the value of p. That is equal to m square plus 9, and here in the second bracket it is m square plus 4 equal to 0. M square plus 9 equal to 0, and m square plus 4 equal to 0. Agree, guys? That means I have m square plus 9 equal to 0 FOIL method, and m square plus 4 equal to 0. M square plus 9 equal to 0. What is the solution, Margi? If you want to answer. Alex?
Yes, sir.
Yes. M square plus 9 equal to, what is the factor?
The factor would be m plus 3 and minus 3.
Okay. M square minus 9 equal to 0. What is the factor? Alex? M square minus 9 equal to 0. What are the factors?
It would be m plus 3 and m minus 3.
So you
Equals
said
0.
that for m
Yeah.
square plus 9 and m square minus 9 factors are same. Are you sure? Are you sure? I hope you are getting me, right?
Yes, I get you, sir.
Yes, Nick. You want to take this one?
There wouldn't be 3i.
Who said this thing? Who is there?
It's Will. Hi.
No, who is there? Queen Heart? Who spoke this thing?
It's Will.
Oh, Joel. Okay. Where is he? Can't see him. Where is
Hi. Right here. I'm a video.
Okay.
Oh yeah.
Will.
Oh,
Look at here.
it
Yeah,
would
he's
be-
right. See, m square plus, so the factors are, look at over here. So it is, so m plus 3i bracket m minus 3i equal to 0. Because if you use the FOIL method, m square, then m times 3i minus m times 3i will get cancelled out. 3 3s are 9. Because of this negative sign, plus and minus is negative 9. And I square, you know, complex number I square equal to negative 1. So this negative and this negative will become positive. So I'm getting m square plus 9 equal to 0. That means your roots are complex conjugate m equal to plus or minus 3i. Because nothing is there over here, so I would like to write m equal to 0 times 0 plus or minus 3i, so that I can compare that one with alpha plus or minus beta times I. Are you getting me? Alpha plus or minus beta times I. Yes or no, guys? All of you are getting me or not?
yes, sir.
Yes, sir.
Okay. Okay. Minus I. My second part is, I'm sorry, let me just, where is it? Eraser. Okay. My second part is, look at here, m square plus 4 equal to 0. Oops, why I'm not able to write? What's wrong with that? m square plus 4. Oops. It's bothering me. That is equal to 0. So again, same way, m plus 2i and m minus 2i equal to 0. That means I'm going to get m equal to plus or minus 2i. That means I can write 0 plus or minus 2i. And this is my alpha plus or minus beta times I. Right? So I have 4 roots. One is 0 plus or minus 3i. Second one is 0 plus or minus 2i. Now, that means I have complex conjugate roots over here, complex conjugate roots over here. 2 roots are here, from here, 2 roots from here, total 4 roots, and order of the differential equation is 4. So that makes sense, right? Now, which type of roots are there? Complex conjugate of each other. That means there is third category. Agree? Third category, that means I can write my solution in the form. So y, always write yc of x. Yc, because right hand side is 0, will give you complementary function. So yc of x, my equation is like this: e to the power alpha x in the bracket c1 cosine beta x plus c2 sine beta x. c1 cosine beta x plus c2 sine beta x. My goodness. Oh, what's going on? I don't like this one. Anyway, C2 sine beta x. So that means I can write yc of x, that is equal to e to the power alpha. What is my alpha in the first case? 0. So e to the power 0x. Actually, no need to write. And here it is c1 equal to c1 as it is, and cosine. My beta is equal to 3i. So 3. So beta equal to 3x plus c2 sine 3x plus, I'm going to write my second solution, 0 plus or minus 2i. E to the power 0x, inside the bracket, only I use c1 and c2. Let me use another constant, c3. So cosine of, now beta is 2, so 2x, and c4 and sine of 2x. C4 sine of 2x. And you can see over here, I have c1 to c2, 2 constants. Another 2 constants are here. 4 constants are here. Order of the differential equation, that is, order of the differential equation, look at over here, that is 4th order. Order of the differential equation equal to number of arbitrary constants. So this is the solution. E to the power 0 is simply 1, no need to write. E to the power 0 is simply 1, no need to write. So c1 cosine 3x plus c2 sine 3x plus c3 cosine 2x plus c4 cosine 2x. That is the answer I gave it to you in the practice test. Make sense? Any doubt? So first of all, what I did, just repeat this one. First of all, I just converted into the operator form. Then after, I converted to auxiliary equation. I solve the auxiliary equation according to the type of roots. I just found the proper category, which type of roots are there, and then after I wrote down the solution. This ycx, because whenever you are writing the homogeneous equation solution, at that time ycx, that is called the complementary function. In future, for non-zero right-hand side, we are going to write another solution that is called ypx, that is called particular integral for right-hand side non-zero. And finally, we are going to add this yc and yp. So always it is preferable to write it down yc of x. If, of course, the right-hand side is not, there is no right-hand side, simply 0. So this yc itself will work as yp. I mean, it's general solution, because general solution y equal to, you know this thing, that is equal to yc plus, in the introduction portion, I told you yp. But here, there is no p, no yp, because right-hand side is 0. So this will disappear. So y itself will work as yc. But always try to practice this thing that it is YC. Okay, guys? May I erase this one? May I erase this part?
Yes, sir.
I'm asking all of you.
Yes, sir.
Yes, sir.
Okay,
Yep.
good. So now let's start with another problem. So that's why I wrote it down over here. I explained to everything here, right? Look at here. This is my solution. My question number 3D, cubic solution. Whenever cubic, see, quadratic by quadratic equation are easier than the cubic equation. Always keep in mind this thing. Cubic solution, if you convert this one in the form of the operator d cube minus 7d minus 6 outside y equal to 0. You have to write the operator form first before you convert to auxiliary form, because operator form includes your y, auxiliary form is out of y. So replace your d by m, so m cube minus 7m minus 6 equal to 0. Now you don't know how to solve this cubic equation. So in that case, always try to use trial and error method. You can use m equal to 0. You can start with m equal to 1, negative 1. Just try to play in between, I mean, it's nearer to 0. 0, 1, 2, 0, negative 1, negative 2, like this. This type of numbers, it may work. Not always, because there are some cubic equations in which you have some fraction or irrational numbers as a solution. At that time, there's a different method that's called Cardan method to solve the cubic equation. We are not concerned about it right now. Right now, I just want the solution just as an integer. So that's why I told you to just try to verify with 0, 1, negative 1, 2, negative 1. Out of this, at least one will be your solution for our examples. Okay, if I write, if I convert this m equal to negative 1, so negative 1 cube is negative 1, m equal to negative 1, so plus 7 and negative 6. Negative 1, negative 6 is negative 7, and this, negative 1 cube is negative 1. M equal to negative 1, so negative positive 7 and negative 6. So negative 1, negative 6 is negative 7, and positive 7 means 0. Right inside 0. That means m equal to negative 1 satisfies the equation. Other way around, m equal to negative 1 means m plus 1 equal to 0. If you take this negative on the other side, so m plus 1 equal to 0 satisfies this equation. That means I can write, so m plus 1 equal to 0 satisfies the equation. That means m plus 1 equal to 0 is one of the roots out of these 3 roots. Will, please pay attention here. Please don't allow anybody in front of you, please.
Yeah, sir, my brother just walked in the room. That's it.
So m cube minus 7m minus 6 equal to 0. So m plus 1 equal to 0 is one of the solutions out of these 3 solutions. So what I'm going to do, just divide this one by this one of the solutions. So m cube, that is just like a long division. M cube minus 7m minus 6 divided by m plus 1. M plus 1 is there, we want cube, so just multiply this factor by m square, so that I will be having m cube as a first term. So m square, so m cube plus m square. Just change the sign, m cube multiplying by m square, this term. So m cube plus m square. Change the sign, this will get cancelled out, negative of m square. Means I'm getting negative m square, negative 7x, 7m, and negative 6. Again, I have m plus 1 here. I want negative of m square, so multiply throughout by negative m. So negative of m square, negative m. Change the sign to cancel this one out. Negative 7m plus m is negative 6m and negative 6. Now, negative 6m and negative 6, multiply this one by negative 6, so that negative 6m and minus 6. Change the sign, this will get cancelled out, and 0 as a remainder. That means this equation can be written in the form of m plus 1, one of the roots, and whatever is left out over here, m square minus m plus 6 equal to 0, that is second root. But this second root is now your quadratic root. So you can use quadratic formula, or you can just use the factors. You can take the factors. Here it is m plus 1, m square minus m minus 6 equal to 0. That is m plus 2 and m minus 3 equal to 0. So m equal to negative 1, negative 2, and 3. 3 roots are there. 3 roots are there. Cubic equation, 3 roots. Again, cubic equation, 3 roots, that must be equal to number of constants as a solution. So all these 3 roots, now look at over here, all these 3 roots, m1, m2, m, they are real number. They are real number, they are not same. That means it is first category. Roots are real and distinct. They are different. And that's why your m1 is negative 1, m2 is negative 2, m3 is 3. Plug these 3 forms, these 3 in the formula, you're going to get y equal to c1 e to the power negative x plus c2 e to the power negative 2x plus C3 e to the power 3x, your M1, M2, and M3. So that's the solution. But again, I would prefer you to write it down, not y, yc complementary function. Any doubt? Any doubt, guys? Please say something.
No, sir.
Okay. Next. M to the power 4x dt to the power 4 instead of independent variable x, here it is t. That's fine. Auxiliary equation in m to the power 4 plus 4 equal to 0. Actually, d to the power 4 plus 4x, it's okay. Right? Now if you take the factor p plus 2i and p minus 2i, but p is m square plus 2i. Already you are having one complex number. How can you get m square plus 2i factor? You can't take it. You can't get the factor. These are typical example. You can't get the factor. It's just simple factors, but you have to be careful. So this method will not work. That means we have to find some other way out. Other way out is making a perfect square. So I have this m square plus 4 equal to 0. Intentionally, I wrote it down. I put the box over here and I wrote it down. Will not work, because so that you can come to know that you have to go through some other way. You have to find some other way out. So m square plus 4 equal to 0. Don't consider this. This is just printing some error. It's simply m square plus 4 equal to 0. What I'm going to do? M square plus 4 equal to 0. If I add and subtract 4m square, so m to the power 4 plus 4m square plus 4 and negative 4m square, adding and subtracting. Why? Because this term now will give you the perfect square, m square plus 2 whole square minus 2m square equal to 0. So it is now a square minus b square form. So a minus b and a plus b. A minus b and a plus b equal to 0. A plus b equal to 0. FOIL method, first part equal to 0 and second part equal to 0. B equal to negative 2. So negative b plus or minus b square minus 4ac divided by 2a. Same here. You are getting 1 plus or minus 1 times I. Negative 1 plus or minus 1 times I. So alpha, because it is negative here. Look at here. So these two complex numbers, they are not same. So this is one pair of complex conjugate. This is another pair of complex conjugate. So roots are complex conjugate of each other, but they are separate. They are not same. That means again, third category. Third category means make sure your independent variable is t here. If you write x, you are wrong. So, and your dependent variable is x in the solution. So x equal to e to the power c, c1 cosine beta. Beta is 1. c1 cosine t plus c2 sine beta is t. E to the power alpha is negative t. c3 cosine beta is 1. c4 sine beta is 1 and t. That's the solution. So whenever you write the solution, be careful. Don't think that only practice test problems are enough. Always please keep in mind this thing that you have to solve plenty of examples to get good command over this one. Otherwise, everything will be wrong. If you are not good, or if your example, if you're not good with this 4.3, just forget about 4.4 article. You are going to mess up the whole example. If you are not, this is just one part of 4.4 article. Whatever we are doing right now, 4.3, I would say that is just a subset of 4.4. We are going to repeat the same thing as one part of the examples for 4.4. So you have to have good command over 4.3 before proceed further. Okay, reduction of order, just the repetition. Example, oh yeah, that's what I told you yesterday. See, Nina or somebody asked me this one. I think Mustaine, he asked me this one, right? The second problem, and we solved this one. But is it? No, it's something different. Anyway, so I think there is one more example for you. Yeah, it is question 2C part. Okay, he asked me B and this one is C. So you're good. This is just the repetition, whatever I did. We solve number of examples. Only thing is you need to practice the examples. It's exactly same thing. Exactly same things, whatever we have covered. Yeah, it's just a repetition of notes, you can say. Okay, guys. So, any doubt in Article 4.3? Any doubt in Article 4.3? Mainly, we went over 4 type of roots. Roots are real and distinct, real and repeated, complex conjugate, repeated complex conjugates. These 4 roots, remember or memorize the general formula. Solve your example, convert your equation in the form of an operator, write the auxiliary solution, solve the algebraic equation. What type of algebraic equation you are getting depends on, out of those 4 forms, you have to use the proper form to write the solution. Okay. May I go for the next one? May I go for the next article?
Yes, sir.
Let's do it, sir.
Go for it, sir.
Thank you. Next article, Article 4.4. This is your formula sheet. Try to listen to me carefully. This is your formula sheet. Take the printout of this formula sheet. One more formula sheet. Don't ask me at the time of the exam. I told you so many times. Whenever I say that this is the formula sheet and take the printout, means it is now your job to keep this thing in mind. How to use the formula, that is more important. You must know how to use this formula. Whenever, this is the formula for your right hand side, YP. Whenever your right hand side is non-zero function, it could be anything. I told you, it could be exponential function, it could be some algebraic function, it could be some polynomial, it could be some trig function, it could be some hyperbolic function, it could be a combination of any 2 of these, it could be anything, or 3 of these, it could be anything. Suppose my right hand side is simply a constant, suppose 2, 3, 4 like this, y double dash plus 4y square plus 4 equal to 2. Suppose that's a differential equation. My right hand side is now not 0, it's 2. Whenever your right hand side is 2, always consider A as always consider yp equal to A as an assumption. Method says that we are going to assume something for your right hand side. If your right hand side is a polynomial of degree 1, consider general polynomial ax to the power 1 plus c plus b. So 5x plus 7, these are the examples. Don't think that you are going to get exactly same. These are just the examples. It could, here it is 5x plus 7. It could be 10x plus 8. It could be anything, but power is just 1. Whenever power is 1, at that time, your assumption of yp should be ax to the power 1 plus b. Whenever quadratic equation is there, any quadratic equation, 5x squared plus 7x plus 9, right? You have to have the general formation ax squared plus bx plus c. We are assuming like this, and then after we are going to take the help of the matrix, your calculator, and we are going to find these constant values a, b, and c, whatever you have assumed for your yp. We will be getting back to plug these values for a, b, and c to fix your yp. And then after we are going to add this, your yc and yp to get the general solution. So there is a theme behind your Article 4.4. Article 4.4. Suppose your cubic equation is there. Assume cubic form, general cubic form, ax cubed plus whatever the power of x you are having over here, you have to have the same power. You have to assume same power with the general formula. Ax cubed plus bx squared plus cx plus e. One more thing. Here you might be wondering that here we don't have power x to the power 1. No worries, please. X to the power 1 is there, not there. Even though you have to consider x to the power 1 over here, you have to have your right hand side in the descending order of x. Power 2, power 1, power 0, like this. You cannot skip any one of these. Power 3, 2, 1, 0. 4, 3, 2, 1, 0, like this. You cannot jump from 4 to 3, and then 3 to 0. No. You have to have descending order including all terms. Even though your right hand side is, some terms of x powers are missing. Even though you have to consider like this. Suppose my right hand side is simply sine x, sine 4x. Sine 4x, whenever sine or cosine is just sine or simply sine or cosine is there, for sine 4x you have to assume sine and cosine both. A cosine 4x plus b sine 4x. You can't change the angle. So don't consider here some m or like this. No, you can't change the angle. Your constant appears over here. Your constant or constants appear over here, a and b. So a cosine 4x and b sine 4x. We are finding a and b. You can't change the angle, please. Suppose you have cosine 5x. So it should be a cosine 5x plus b sine 5x. This will be your assumption. E to the power 5x. Your assumption should be, again, e to the exponent power. You cannot change the power. You are working only with the coefficient. So a times e to the power 5x. Suppose I have 9x minus 2 and this is now the combination. This is the polynomial. 9x minus 2 is same as 5x plus 7, power 1. But it is multiplied by the exponential function, means 7, e to the power 5x. Means 8 is the combination of 2 and 7. Combination of 2 and 7, that is your 8. So whenever you have this type of combination, for 9x minus 2 means 5x plus 7, your assumptions was ax plus b. Assume ax plus b. Ax plus b. Because you already assume a and b over here like this, you don't have to do anything, just write your exponential function e to the power 5x, because constants a and b, whatever you are required to write it down by 7 already comes automatically through 2. So that's why 9x minus 2, this polynomial can be written in the general form of power 1 ax plus b e to the power 5x as it is. Don't change exponential power, please, or coefficient of x in the exponent. Suppose you have a combination of exponential function with the trig function. Exponential function keep as it is. Trig function, I would like to write this one as other reverse way. Sin x 4x first and e to the power 3x second. Sin x 4x means e to the power 3x means it is 7 type. Sin 4x means it is 5th type. So now it's a combination of 5 and 7. That means sin 5x, sin 4x can be written as a cosine 4x plus b sine 4x. A cosine 4x plus b sine 4x. And that's what I did. See here, a cosine 4x plus b sine 4x plus b sine 4x. And e to the power 3x as a multiplier as it is, just like your previous term. So a cosine 4x plus b sine 4x, a and b are already included. So e to the power 3x here. Suppose your x square means polynomial, second number. This is the product of, or I would say, combination of 3 and 7. X square e to the power 5x. Because it is square, you have to have square is there. So ax square plus bx plus c descending order, including all the powers 2, 1, 0, and e to the power 5x, like this. X square, quadratic function with the trig function. So ax square plus bx plus c for here. And in second bracket, sin 4x can be written as cosine 4x plus sin 4x. But make sure that, see here, actually, okay, number 11, please pay more attention. 5x square sin 4x, right? Because my x square is, quadratic function is ax square plus bx plus c. And sin 4x is written in the form of a cosine 4x plus b sin 4x. So for a cosine 4x, I don't have any problem because my constant a is assumed over here in the form of quadratic term. So ax square. But what is about this b? For sine all, again, I have to have this quadratic formation. So ax square plus bx plus c, and here I can write another constants, e, f, and g. Don't write d because d stands for an operator. So don't write d. Intentionally, I change this one, a, b, and c, and then e, f, and g. So ex square plus fx plus g and sine 4x. Sine 4x. Last one, 12, is a combination of 3 functions, x to the power 1, 3x, and cosine 4x. X to the power 1, number 2, ax plus b. So ax plus b. E to the power 3x, we always keep like this as it is. Cosine 4x is sine cosine 4x and sine 4x. Cosine 4x is written in the 2 forms, cosine 4x plus sine 4x. So cosine 4x here, but for sine 4x, I have to have another 2 constants. So cx plus e to the power 3x sine 4x. So these are the standard formation for this type of combinations. Whatever 1 to 12, I give it to you. Take the print out. Then after we'll talk about this article 4.6, not today, tomorrow. Let me start one examples. I am going to solve 1 or 2 examples today, and then after I'm going to repeat the same method, at least for 1 example tomorrow, and then after we will switch over to the next article. So tomorrow, in short, I'm going to repeat one example based on this method. Article 4.4, undetermined coefficient. Undetermined coefficient. Does it make sense? Do you need some time to look at this formula, guys? I give you 1 minute or 2 minutes just to look at this formula. Try to understand why this 3x square minus 2 is converted in this form. Try to convince yourself. If you have some doubt, ask me. Just 2 minutes, time starts. Excuse me. Done? Yes. Any question? Okay, guys, let's start one example very slowly. All of you, please pay your full attention. I told you yesterday that please keep some stimulator with you. I told you. But I think you guys don't want to follow me. Yeah, if it is required, that's not compulsory. It's not mandatory. If it is required, or if you want to have some stimulator, I can give you another 2 minutes, 2-3 minutes. Go and grab it. And if you feel that all you guys are good, I don't mind. I can continue. Ismail Taylor, where are you? Okay, all you guys are here. Nathan Light, are you okay? Not Light, are you okay?
I'm fine.
Keep smiling. Don't get tensed. Okay, Gage Levine.
Yes, sir.
Queen, I hope you are good, right?
I'm good, sir.
Good, good. Nick?
Doing great, sir.
Good. Okay, Harris Solomon. Good.
Yes, sir.
Nice. Ilyas, work hard.
Yes, sir.
Yeah,
Will do.
work hard. Will is good. Alex is good. Nina, okay? Okay, guys, let's start. My first example. Method of undetermined coefficient. I want all your full attention here on the screen, please. All of you. Don't write anything, just try to understand this first example. If you are done with these first two examples, you are done with the article. Y double dash plus 4y dash minus 2y equal to 2x square minus 3x plus 6. consider right hand side equal to 0. Yeah, even though it is non-zero right now, just for the sake of convenience, consider right hand side equal to 0. That means you are in the form of article 4.3 homogeneous linear second order differential equation, y double dash plus 4y dash minus 2y equal to 0. Auxiliary equation is m square minus 4m minus 2 equal to 0 without y. Take the factors. Quadratic equation is there. Factors are negative b plus or minus b square minus 4 times ac divided by 2 times a. A is 1. A is 1. Separate it out or just use simple algebra. Negative 2, 4 divided by 2 is negative 2, and this divided by 2 is 4, 6 are 24 by 2. 24 can be written as, yes please, square root of 4 is 2, and this 2 and 2 will get cancelled out, so square root of 6. So negative 2 plus or minus root 6. Make sure it is negative 2 plus or minus root 6 is not root 6i. There is no i. It's just a simple number, irrational number. Just irrational number. So yc of x, hello, I'll call you back. Is it okay? Yeah. Sorry guys. Yc of x equal to c1 e to the power negative 2 plus root 6x, because one of the roots, both are real number, negative root 2 plus root 6 and negative root 2 minus root 6. Don't think it looks like a complex, but no, there is no I. It's a real number. So c1 e to the power m1x plus c2 e to the power m2x. Let me write 1 over here. This is the solution of my left-hand side homogeneous equation. Now I'm going to take care of my right-hand side. Right-hand side is not a combination. It's simply a second-order polynomial. Second-order polynomial, right? What should be my assumption, guys? Here is, what should be my assumptions for yp? What should be my assumptions for yp? Go ahead. It's a second order polynomial. Second order polynomial means ax square plus bx plus c. Agree?
Yes, sir.
Sure.
Good. Ax square plus bx plus c. So my yp equal to ax square plus bx plus c. Now look at here, guys. Guys, please pay attention. I told you, otherwise you are going to miss lots of things. Ax square plus bx plus c. How many derivatives I have on left side?
2.
2. Highest derivative is 2. So take 2 derivatives. Here yp, so yp dash equal to 2ax plus b, yp double dash equal to simply 2a. Agree?
Yes, sir.
Before you compare your yp over here, how many derivatives are there on left side? Compare your yp with your yc, your assumptions with your yc. Irrespective of constants, there should not be any matching terms. Here you can say that x square is there. I don't find any x square terms over here. It's e to the power x. Here x to the power 1 is there. I don't have simply x over here with some constant. One constant is there. I don't have any constant over here. Only constant over here. Constant is multiplied with by the exponential function, but not simply a constant, right? Whenever your yp must be different from your yc. Sometimes it may possible, try to pick up my words. Sometimes it may possible that ax square plus bx plus c, any one of these, this equation, this quadratic equation, the same form, irrespective of constants, please, you may get over here. And that is called a glitch. It will create a glitch. Whenever your yp creates a glitch, you cannot proceed further. You have to consider your yp first out of glitch. You have to have your yp out of glitch. Once your yp is out of glitch, means there is no matching terms with yc. Only after that, you are allowed to proceed further. You cannot work with the glitch part. You will be wrong. Getting me? Getting me?
Yes, sir.
Good. Here there is no glitch, and that's why I wrote it down. here to here, no glitch. You also try to practice like this, that no glitch. I want this word, no glitch. No glitch means I will assume that you understood the problem till yet thoroughly. Because it is no glitch, and then after I have to compare my YP, or I have to look at how many derivatives are there. Highest derivative is there on left hand side, YP dash, second derivative. Let me take two derivatives over here. What are the numbers I'm getting over here? Guys, look at here. Plug these numbers over here. Y double dash, I am replacing by 2a. YP dash double dash. 4 times Y dash is replaced by 4 times YP dash. So 4 is multiplied with this term. And negative 2y, y is yp, negative 2 is multiplied with this term. And my right hand side as it is, whatever I provided to you, whatever is given to us. Look at my next term. My yp double dash is 2a, 4 times. See, I use the curly bracket so that you can come to know the difference is 2ax plus b is my yp dash. Negative 2 I multiplied with this one. And that's how everything here on left side is in the form of A, B, and C, and right hand side is whatever is given to us. Any doubt?
No, sir.
Asking you guys, any doubt? Okay.
Yeah.
Your next target is to write your left side in the descending order of x so that I can compare my left and right sides. So descending order of x. Here it is x square, 1 and 0. Same way I want to write my left hand side. You have to. So my highest power, just open the brackets first. So here it is 2, 4 2s are 8, a and x. Okay, power of x is 1, but here it is 2. So negative 2ax square is the highest order, highest term I have. So let me write it down first, negative 2ax square. Then after I'm having x over here, so just put one mark over here, x over here. I am having x over here. Let me combine these two terms. So 8ax and negative 4bx. 8a and negative 2bx, negative 2b. 8a minus negative 2b and x outside. Then after I'm going to collect all my constant terms. So here it is constant, here it is constant. So let me write, and here it is constant. So let me write 2a, 4b, 2a plus 4b and negative 2c and x to the power 0 equal to this one. Agree? Yes or no?
Yes, sir.
Now I can compare my
Yes,
so that my negative 2a equal to 2. Negative 2a equal to 2 means a equal to negative 1, very simple, right? So I'm getting my first constant in my yp, a equal to negative 1. Agree? Then after, let me compare my x to the power 1. 8a minus 2b equal to negative 3. Already I'm having a equal to negative 1 here. Let me plug over here a equal to negative 1. So negative 8 minus 2b equal to negative 3. Solve this one, you're going to get b equal to negative 5 by 2. Compare my third term, 2a plus 4b minus 2c equal to 6. Plug the value of a, negative 1, b, negative 5 by 2. Solve this one, you're going to get c equal to negative 9. C equal to negative 9. Go back and plug all these values and see your assumptions, yp. So a equal to negative of x square, negative 5 by 2x and plus 9. That is my yp. Look at here. And that is number 2. I don't write C or like this because I told you constants are merged. Already you are having constant over here in your YC. So this YC plus this YP, YC plus YP, that is the general solution. You have to repeat the solution like this. YC plus YC. So up to here it is YC and this is my YP. This is my YP. That is the answer. Now, here I have, because it was very, very simple, so I just used my algebra skill and solved these 3 equations. But sometimes it is hard to solve. It's not hard, but lots of work to solve these 3 equations. What I would prefer is to use the matrix. Use matrix. I don't know whether I have some matrix formation over here or not. Okay, no, it's not here, but that's fine. I can teach you how to use the matrix. So let's go like this, guys. Look at here. Let me write it down, these 3 equations in just one piece of paper. I'm not going to use the tablet because I want to show you these three equations. First equation is what? A equal to -1 or -2a equal to 2. My second equation is 8a minus 2b equal to -3. My third equation, I'm just looking over here at my main, just comparing terms, first line. So I have 2a plus 4b minus 2c equal to 6. Can I get this type of things, guys? Look at here and look at my way of writing. I brought it down, a below a, b below b, c below c. Agree? Agree?
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Okay. Now, shall I write? I'm changing the color now so that you will realize the things what I actually mean. So, shall I write like this? Plus 0 times b plus 0 times c plus 0 times c. Shall I write like this? I just added 0 times something, 0 times something. Agree?
Yes, sir.
Something.
Yes, sir.
Right? Now I can write the same thing as, just consider the coefficient. -2, 0, 0, right hand side is 2. A, -2, 0, right hand side is 3. 2, 4, -2, right hand side is 3. Shall I write in the matrix form like this? Shall I write in the matrix form like this? Please say yes.
Yes.
Yes, sir.
Yes, sir.
Right? Use your calculator and give the command RREF. So you are going to get, for this command, you're going to get 1 0 0 0 1 0 0 0 1. Your A was -1, B was -5/2, and C was 9. So this is your A, B, and C. After giving the command in your calculator RREF, you will be getting like this. Means I can say that A equal to -2, B, A equal to -1, B equal to -5/2, and C equal to 9. And I can go back and plug that value in my YP. Agree?
Yes, sir.
Yes.
Any doubt, guys? Any doubt?
No, sir.
Nope.
Girls?
No, sir.
Margie?
Yeah, no, I'm good.
Hey guys, is the solution of your equation. Make sense?
Sir, I had a question.
Yes.
So I understand like how we got the solution and
Who is
everything.
there? Just give me your name first because I can't see your face because of this screen sharing screen.
It's Ishmael Taylor.
Taylor. Okay, okay, Ismail Taylor. Go ahead.
Yeah, so I could you just go over the glitch again? Like
I have not taken any example so far based on glitch. Glitch, of course, I can go over the glitch, but I am going to take the examples and I will explain to you more than 3 times, right? In that example. Anyway, requests are always most welcome. So let me go through the glitch part again. Glitch part means once you assume your YP, try to pick up my words. Once you assume your YP, you have to assume this you have to compare your YP with your YC. And there should not be any common terms like this. Here is a quadratic equation. You should not be having any quadratic term over here with some constant. Here it is C1, here it is A. Suppose here it is 2. And I don't bother about constant, but there should not be any quadratic terms. Are you getting me? You will not come to know this thing thoroughly right now. I have to examples to explain to you. So that's why I told you just have patience, just wait.
All right, sir.
Okay? Definitely, I will take care of that part, don't worry. Or I can take that part right now. Give me one example. Okay, let me share my screen. And you want glitch, right? Yes, Ismail. Let me give you the priority. Let me stop this. And I want one example, guys. Open your practice test. What is the example number 3? Right. I just want right hand side. Somebody please speak it for me. Example number 3, question 4. Go ahead.
From the practice test, right?
Yes.
So you mean D? Or C from number 4?
What is C? I just want to know what is C.
The right-hand side is e to the power 2x.
Let me clear the clean. Okay. Yeah, go ahead. What is right hand side?
It's e to the 2x, and then cosine
Cosine.
x.
No. Okay. Next example.
Next one is just e to the x.
E to the x? Just e to the x?
Yes, sir.
Okay. So go ahead. Give me the full example.
Y double prime minus
This is
2.
question. Oh, sorry. This is question number.
D.
Question number 4.
4D.
D. Right?
Yes, sir.
Question number 4D. Okay.
So it's y double prime minus 2y prime plus y.
One minute. You said y double prime minus
2y prime.
Then
plus y equals e to the x.
Okay, guys, all of you please pay attention here. So first of all, my operator form is d square minus 2d plus 1 outside y equal to 0. That is my homogeneous equation. So auxiliary equation is m square minus 2m plus 1 equal to 0. And this implies that m minus 1 whole square equal to 0. And this implies that m equal to, what are the values of m? What are the values? What is m?
M equals 1 and -1.
No. Why -1? It's simply 1 and 1 because square is there. M minus 1, M minus 1. So 1 and 1. That means roots are real and repeated. Agree? Real,
Yes, sir.
Real and repeated. That means I have to have my yc of x that is equal to c1 e to the power m1x plus c2x e to the power x. Agree? Plus c2x e to the power x. This is my complementary function yc of x. Now, I'm going to assume yp of x that is equal to, right hand side is simply e to the power x. Look at here, guys. So I'm going to assume formula number 5 or what it may be, e to the power x, a e to the power x. But now what will happen? Please pay attention, guys. All of you, Paul Mustaine here. I want all of you here, please. Please smile. Can you see this is my constant and e to the power x function? And I have one constant over here, c1 and e to the power x. And I told you that we don't bother about the constant, but it is almost same function, that e to the power x and a to the power x. Am I right?
Yes, sir.
That means it creates the glitch. And that was not the case in my first example. Yes or no? Yes or no?
Yes, sir.
No.
That means I have to mention like this because this is the glitch. 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 What is the way out is multiply, again write yp. Multiply your yp by 1 more x. So I am going to write ax e to the power x. Agree? That's the method.
Yes, sir.
Multiply your yp by 1 more x to get rid of this glitch. But again, guys, look at here.
Still a glitch.
Again, this my second function, it creates the glitch with my second part. Look at here. Because here it is x e to the power x. Agree? It creates a glitch. So still I am not allowed to proceed further. That means this creates a, oh my gosh. It creates a glitch. So one more time. Yp of x equal to ax square e to the power x. Do you find any glitch now?
No, sir.
Happy? Smile?
Yes.
Smile.
Yes, sir.
So there is no glitch. Once there is no glitch, now I'm allowed to compare how many derivatives are there on my left. Derivatives are there. Look at here, 2 derivatives. That means I have to go for now 2 derivatives whenever my function, my yp assumption is off glitch. So I can write like this now. Yp dash of x equal to, it's a product rule. So 2ax e to the power x plus ax square e to the power x. Ax square e to the power x. My yp double dash of x equal to 2a e to the power x plus 2ax e to the power x plus 2ax. So naturally it is 4ax e to the power x and ax square e to the power x, right? Derivatives. Sorry, derivatives. Go back and plug all these 3 values, yp dash and yp double dash in my given equation. Yes or no? That's what
Yes.
method says. So now my yp dash will be, I'm going to get 2a e to the power x plus 4ax e to the power x plus ax square e to the power x minus yp dash is multiplied by -2. So negative 4ax e to the power x, negative 2ax square e to the power x, right? And then simply my y, so yp. Yp is ax square e to the power x, and that is equal to e to the power x. Agree? That is equal to e to the power.
Yes, sir.
All of you agree with me or not?
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Sir.
Any doubts so far?
Yes,
Sounds
sir.
good. So you can cancel the common terms. You can see over here, I'm cancelling by this term with this term. Then 2a and ax square. Then ax square will get cancelled out with negative 2ax square. So what is left out? Everything is cancelled out. So I'm going to write that is equal to 2a e to the power x, 2a e to the power x equal to the power x. So naturally my a equal to 2a equal to 1. So a equal to 1 by 2. Agree?
Yes, sir.
Equal to 1. And that was the only constant I will be having. Now don't plug this a equal to 1 by 2 in the first equation. It has to be in your non-glitch equation, please. If you're going to plug it over here, you will be wrong. Right? It has to be in the non-glitch portion. That means I can write my yp of x equal to a is, where is my a? A is, sorry, 1 by 2 x square e to the power x. This is my yp. And finally, y equal to yc plus yp is my solution. Happy?
Yep.
Sir.
Now you can write it down if you want. And let me stop over here. I think it's almost 11:40 and I don't want to give you any stress. So I just want you to go through all these examples. Guys, please don't disappoint me. I will be upset tomorrow if I find a single one who has not gone through the classwork. I don't want to listen to any excuse, please. And I will see your face and I will come to know this thing and I will intentionally ask you the questions. So please don't do this thing. Don't disappoint me. Don't make me upset, please. This is my request. Today is a request. Tomorrow it will not be a request.
Today, sir, we covered all of 4.4.
I have not covered, not completely 4.4. I just want you to go through my class notes. That's it.
Okay.
And if you want, you can cover the examples till question number 3, end of question number 3. Okay, I have not finished article 4.4. I'm going to take a couple more examples tomorrow because I want to spend some more time with you guys for this article. So tomorrow, that is article 4.6 and maybe 4.8 last article. And day after tomorrow, or no, 4.8 little bit. Day after tomorrow, 4.8. Immediately after that, I'm going to start the review session, Friday exam. I told you we are on schedule. And I'm very particular about the time. Whatever we have decided, we have to have that. We have to finish that thing. That's what my nature and that's what I want you guys to do. Hello? 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 Okay, guys. You want me to erase? I'm just stop the screen. Or if you want, you can take the picture. If you want, you can write it down. I can wait for you. It's up to you. What do you want, guys?
I'm gonna take a picture real quick, sir.
Okay.
I'll write that quick.
Okay.
I got it. Thank you.
Okay, no problem. Shall I stop this video, guys? Or if you want, I can let me stop sharing this one and I can close this video. Is it okay, guys?
Yes.
Yes, sir,
All
that
of you,
works.
Yeah,
girls?
that's fine with me.
Okay, guys. So tomorrow, Will, please spare some time for this one too. Okay?
Yep.
Good,
Yeah.
good. Okay, guys. Stay safe, stay healthy. Have a good rest of the day. Thank you
Thank
so
you,
much
sir.
for your
You too, sir.
cooperation. Thank you. Thank you,
All right,
guys.
sir. Have a good day.
See you tomorrow.
See you tomorrow. Thank you, guys. Take care.